Hello student, in this lab session also we are going to see new techniques, multiplexing techniques. Already you know what is multiplexing. In multiplexing we are combining several user information into one channel and send it, and in other side we will do the demultiplexing, and we can separate user information separately. So that is the idea of multiplexing. We are combining several information into one channel and send it through one channel. Okay. So that combining several information in combining several user information into one channel we normally referred as multiplexing, and in other side we are separating several user information separately. So that is called demultiplexing. Okay. So here we have demultiplexer and multiplexer. All together we called it MUX. Okay, MUX. So in MUX we are doing multiplexing and demultiplexing, both multiplexing and demultiplexing. So in this lab session we are going to demonstrate time division multiplexing. Okay. So normally you know that time division multiplexing we are normally used in digital domain. Okay, but we can use it into analog domain also, but generally time division multiplex is a digital techniques, digital multiplexing technique normally used in digital domain. Okay. So I would like to tell one or two points. Okay. So you know that in digital communication system, we represent our information using 1 and 0. Okay, 1 and 0. So normally information, one user information may be a binary sequence, 1 and 0 sequence. Okay. So when we want to send it or we want to process it through electronic circuits, we have to convert that 1 and 0 into electrical signal form, no? Otherwise we can't process it. So normally there are many, actually that process is called line coding. Okay. So there are many line coding methods available, none return to 0, NRZ line coding, RZ line coding, so on. Okay. So in NRZ that is the most simplest line coding methods, line coding techniques. So normally we assign one voltage to 1 and different voltage, low or high voltage, to 0. Okay. For example, we can assign 5 voltage to 1 and 0 voltage to 0, so on. Okay. So that is NRZ line coding. Okay. So normally, so ultimately I want to tell you is that we represent our signal through voltage levels. Okay. Voltage levels for separate bits, separate information bits. Okay. For example, 1 5 volt, 0 0 volt, so on. Okay. So you already know that the bit there should be a bit interval, bit duration. So if we keep that 5 volt up to some duration, that is the bit duration. So you already know this information, so we no need to talk much about that. Okay. So so in time domain, time division multiplexing also we are going to combine several bits from several users. Okay. Several bits from several users. Okay. So in time division multiplexing, normally we divide our channel using time duration. That means we assign a special time duration for one user. Okay, so that time duration is called time slot. Is called a time slot, no? Time slot for one user. Okay, and by combining several time slot for several users, we construct a time frame. Okay, so that time frame will include several time slot. Okay, and each time slot is assigned for one user. Okay, so that one time slot, okay, if we consider one time slot, that time slot have one user information, other time slot have another user information. Okay, so normally you know that user informations are represented using 1 and 0. Okay, so in one time slot there should be sequence of 1 and 0, no? That one particular user information. Okay, so I hope you can get the idea. Okay, so here in this lab session we are going to do the same process. We are going to map several user information to one channel using several time slot. Okay, so we normally assign, okay, so we can assign one time slot can contain maybe 1 bit, 2 bit, 0 bit, there are many bits. Okay, it's depend on the techniques we are using. Okay, here we no need to talk about much about that. Okay, so here in this lab session we are going to map 1 bit to one time slot. Okay, so that 1 bit represent one user information. Okay, that is what I want to tell you. So if I summarize what I have told you, that here we are going to demonstrate time division multiplexing. Okay, normally we are used time division multiplex in digital domain. So we are going to assign one time slot for one user information, 1 bit. Okay, and we have combined that several time slot, and we will form one TDM frame. Okay, time frame. Okay, that time frame consists of several user information. Okay, and those informations are divided or separate using time. Okay, that is what I want to tell you. Okay, we are going to map 1 bit of one user. Okay, in this session. Okay, now we are going to see how the time division multiplexing is happening and how we can demultiplex the signals. Okay, so here you can see our modulation multiplexer MUX. Okay, multiplexer and demultiplexer time division. Okay, so actually here here this chip, okay, this IC is the multiplexing multiplexer IC, multiplexer part. Okay, and this one we use for demultiplexing. Okay, so the information about these chips are available in your lab sheet. So if you want, you can refer them, and if you want, you can get the data sheet and refer how these chips are working. Okay, so this is our multiplexer and this is our demultiplexer. Okay, and here we have a data generator. Okay, data generator, but in this lab session we are not going to use this part. Okay, and this is the address generator. Okay, this is address generator part. So here you have two ICs. You can see that this is a clock generator. Okay, clock generator IC, and this is the address generator IC. Okay, so this address generator play a key role in this multiplexing process actually. Okay, actually this address generator will assign particular time to one user. Okay, so I will explain it more using our manual. Okay, so you can see that. Okay, so this is our lab sheet. Okay, you will get this sheet. Okay, so you can see that. Okay, in this multiplexer, so this is our manual. Okay, lab sheet. So here you can see that. First thing you should note that we have 8 data bits. Okay, 1 2 3 4 5 6 7 8. Okay, so this one pin is assigned for one user actually. Okay, so you have 8 user input here. Okay, that means you can combine 8 user information. Okay, 8 user information here. Okay, so this is first user, second user, third user, so on. So up to 8 user, you can combine those 8 users information into one channel. Okay, so this is the input of the multiplexer. Okay, and this is the output of the multiplexer. You can see that only one output is there. No, that means we using this multiplexer, we combine all these user information, 8 user information into one channel. Okay, so we get one output. Okay, so this can be directly transmitted. Okay, so hope you get that idea. Okay, and we know that, so I already explained you that one user will assign one particular time duration. Okay, for that particular time duration, this chip will read that user information. For example, first 5 minutes assigned for this user, first 5 seconds, or let's say t time, t second time. Okay, capital T time. Okay, so here that time this multiplexer will read this user information. Okay, then he will map it to the frame, into a frame. Then after that duration, this chip will read other information, other user information, this port. Okay, that means this port. Okay, then he will map that information into that second time slot. So after that time is after that time finished, this multiplexer will read this port. This is third user, no, third user information. So he will map that information into that third time slot. Okay, so likewise, this multiplexer chip will read this port, this input port with a particular time duration. Okay, and map the information available on that port to the time to particular time slot. Okay, and form, after reading all the ports, he automatically generate the time slot, time frame. Okay, then that time frame can be sent through the channel. Okay, so that is the idea. Okay, so we have to assign, so anyway we have to give some information to this chip. Now read this port, now this port should be read, this port should be read, so on. No, we have to give instruction to this multiplexer, this time, within this time duration read this port, then other time duration read this port, so on. Okay, so that part is done using this address generator. Okay, so this address generator parts, okay, address generator will play, okay, address generator plays a key role in this modulation process, modulation and demodulation process. So, this clock is there to give the time information to this address generator. Okay. So, I will, okay, I hope you can see the manual, your data sheet. Okay. Okay. So, here you can see that there are 3 address port, 3 address port. Okay. So, you can see 8 output port. Okay. So, this each output port has been assigned with a particular address. Okay. So, this one particular port has been assigned with one address. Okay. So, you have 8 port. Okay. So, you have 8 port. So, you should need 8 address to address each port. Okay. So, you should have at least 3 bits, 2 to the power 3 you will get 8. So, you should have at least 3 bits to address, to give unique address to this port, 8 input port. Okay. So, that is given using this address generator. Okay. So, you can see the assignment. Okay, assignment 0 0 0 is assigned for B0, 0 0 1 is assigned for D1, 0 1 0 is assigned for D2, so on. Okay. So, 1 1 1 assigned for D7. Okay. So, when this address bit has 0 0 0 value, then this multiplexer will read the port 0, D0. Okay. And after that, after some time, okay, after particular time that assigned for one user, okay, so this address will be deleted and address generator will give this new address 001. Okay. That means the multiplexer will read this D1 port. Okay. So, this D1 port. Okay. So on, he can read all the ports. So, if you allocate some time to particular address, if you allocate some time, okay, for example, if you allocate this 0 0 0 5 microsecond and this 0 0 1 another microsecond, so on. So, that will be our time slot duration. Okay. So, I hope you get the idea clearly. Okay. So, you can see that. Okay. So, again I will tell. So, you have address bit generator and you have a clock there. Okay. So, this address generator will generate 8 address, and at that so it instruct to this multiplexer. Okay. It gives the information to this multiplexer which output port should be selected. Okay. So, I think you can understand this can be implemented very easily using a logic circuits, no? Okay, this kind of okay. So, we will I hope you get a clear idea of how this mux is working. So, we will do our lab session. Okay. So, at the beginning I told you that I am not going to use this data generator. Okay. Instead, I am using this 5 volt pin. Okay. So, here I can get 5 volt repeated by 5 volt. Okay. So, if we see it on our oscilloscope, okay, you can see that, okay, you can see that our DC level is shifted, no, shifted. So when I remove it, you can see it is shifted below. When I give 5 volt, it is shifted above, okay. So that means this is 5 volt line. So we have 5 volt continuously. So we have 5 volt, so we can see the 5 volt value here, okay. Okay, so if you can see the peak value also, you can see it as 5 volt, okay. So we will see, okay. So I use this as my information bit, okay. So this is for one user information. So that user have 5 volt continuously. That means that user have 1 1 1 1 1 so on, okay. So I hope you get the idea, okay. So this is one user, okay. So I connect one user to this port, okay, the multiplexer input port, okay. Then I get the output of the multiplexer, okay. So I give one user information to one port, and other users are not connected, is still not connected, okay. So only one user is there. So it has 1 1 1 1 1 information, okay. It is not a practically in practical system, it is not like this. This user have arbitrary sequence, no, 1 0 1 1 0 so on, but here we gave 1 1 1 sequence. That means 5 volt, we are giving 5 volt constantly, okay. So we can see clearly what happened there, okay. That is why I given that continuous 5 volt, okay. So if I see if you can see now, what you can see only one 5 peak, no, okay. Here you can see only one 5 peak, okay. So what's happened there actually? So that means this address, so I have already told you that when this address bit address generator set 0 0 0, it will read this slot, this D0 slot. Our information has been connected to that slot 1, port 1, okay, port 0 here, okay. So it has some duration, okay, it has some particular time duration. So that is this duration, okay. So this duration from here to here, that duration is assigned for this port, okay. So this multiplexer will read that information within that particular time, okay. So this is the first time slot, okay. So this is the time slot assigned for first user, okay. I hope you get it, okay. And you can see that, okay, you can see that, sorry, you can see that after some time again it is reading, no, again we can see the port 1 information there, okay. So what's happened here? So address bit, now this address bit select address generator assign 0 0 0 for one particular time. At that time multiplexer read the port 0 up to here. Then this address bit is changing after particular time, address bit is changing to 0 0 1. At that time he read this multiplexer will read this port 2, second user, but no information there. After that time third user, no information there, fourth user, no information, sixth user, so on. he will read 8 user, other 8 there are no information. So, after reading that one, again he read the first information, first user information. So, again first user information has 1. So, here again he read that information here. So, you can see that this is for one time slot assigned for each user, and from here to here it is our time frame, no? That time frame is assigned for 8 users. So, I hope you get the idea. Okay. So, if I connect another user, okay. So, another user also I am going to give ones, continuous 1. That means I am just simply give him continuous 5 volt. Okay. That means he has his information continuously 1. Okay. So, I use it as D5 or something. Okay. Okay. So, you can see that. Okay. Now, you can see like this, then I connect it to D4. Now, you can see another information is there, no? Okay. So, that means, okay. So, here what happened is the multiplexer will read the first information. After address bit is changing after some particular time, he will read the second user, third user, fourth user, and this is the fifth user information, and fifth also I have given a 1 value. So, he will read it. Okay. And seventh user, eighth user, so on he read, there are no any information, and after that he again read the first user information, first port. Okay. So, this is first port, then third port, fourth port, second port, third port, fourth port, then fifth port he is reading, then 6, 7, 8, after 8 he again read the first port. Okay. So, that from here to here one time frame, and this is one time slot for first user, and this is the time slot for fifth user. Okay. So, I hope you get the idea. Okay. So, if I connect several bits to several users, okay, you can see that we have that bits here. Okay. So, you can see now here I have so you can see here, so this is our first information. Okay. And second, third, fourth, this is our fifth information, and 5, 6, see this is our seventh information. So, from here to here it is one time frame. That means all information users, all the users informations are there. Okay. But here we have given only first user, second, third, fourth, fifth user, 6, 7, 8 user information 1. Okay. So, he will read that information. Okay. So, I hope you get that idea. If you connect more and more users, okay, you will get like this. Okay. Okay. So, I hope you get the idea. Okay. So, so you can see that this is the output port, this is the output of the multiplex, time division multiplexer. So, you can see that we have sent several information through one channel, through this cable, no. So, this is one transmission channel. So, we have combined several user information. Okay. Here we can combine 8 user information into one channel using this multiplexer, time division multiplexer. Okay. So, if you give it to the, so this is the transmitted signal. So, this should be transmitted through our channel, say it is a line guided media, this copper wire. Okay. So, at the destination we should have the demultiplexer. Okay. So here we have the demultiplexer, time division demultiplexer, and I have put my all information, all user information to the input of that multiplexer. Okay. So I should so that demultiplexer also have, you can see that sorry, 8 port, 1 2 3 4 5 6 7 8 port. Okay. That means that one port, this particular port is assigned for particular user, one user. Okay. So we should be able to get the user information from this cable also. So I have given, you can see that I have given I have connected first user, second no, third user, fourth no, fifth user, sixth no, seventh and eighth user. So you can see that from, if I see the first user information, one pulse should be there, no, one information should be there. Yeah, you can see it, no. So you can see it, one pulse is there and it is the inverted pulse. Okay. So here we have a inverted pulse. So from here we will get -5. Okay. So we can shifted it to we can DC shift it to 10 volt, then we can generate again 5 volt. Okay. So here anyway you can see that -5 volt is inverted output. So here we have inverted output. So -5 I have. Okay. So if I check the second user, there should not be a pulse, no, there should not be a information, because we didn't put any information to that port. Okay. So here we have connected fifth port. Okay. So if I connect the fifth port, there should be a signal. Okay. So if I connect, if I check seventh and eighth also. Okay. Okay. So I hope you get the idea. Okay. We have done the multiplexing. Okay. That means we have combined several information into one channel using time division multiplexing method. In time division multiplexing, we have assigned particular time slot for one user. Okay. So after combining those time slot, we have construct a time frame. So that is called TDM frame, and that frame is sent through the channel, no. So I hope you get that idea. Okay. And also demultiplexer is also the working principle is same. So this address generator will give the instruct to this demultiplexer, map the output value to map the particular value to these users ports. Okay. So I hope you get that idea. Okay.